Afternoon, everyone. So, what I'm going to show you guys now, in case you're stuck on the homework, is a couple examples here of what we've talked about already and see if you are stuck to help you maybe try to work through it. So, I'm taking number 1 and number 3, which we started in class, and I'll review them here online. So, determine for each graph, write a description of motion, an equation, and a motion diagram. So, we'll start with the motion diagram because I always think that's the quickest representation to see if, to check for understanding here. So I'm going to set up my axis and just reference a 0 position here. This doesn't mean where the object starts, it's just for reference. And we see an object traveling 80 meters per second in one direction, and that's the positive direction, and it's decreasing its velocity. So I'm just going to represent this with 3 velocity arrows, v1, v2, v3. I could do 8, but I'm just choosing to do 3 because it's a little bit quicker and it saves time on this video. So my change in velocity would point in the opposite direction of the motion. That's my motion diagram right there. I can see clearly that it is decreasing velocity. The velocity arrows are getting smaller, but they're still positive, and it's still moving to the right the entire time. So then to figure out the acceleration, all right, I have my equations that you're going to be given on each assessment. So we'll look at this and say, oh, I know my initial velocity and initial time. I also know my final velocity and final time. I can determine the acceleration by using the change in velocity divided by the change in time. That would be 0 meters per second if I use the point down here and the point up here. 0 meters per second minus 80 meters per second all over 10 seconds. Sorry. All over 8 seconds minus 0 seconds, which would give me a negative 10 meters per second per second. So that would be my acceleration. Now I could also write an equation for the motion. So a general expression equals negative 10 meters per second times the time plus the initial 80 meters per second. All right. That would be the general equation for that motion. All right. Now to figure out the final velocity, you substitute in 6.5 seconds for time, and you get negative 65 meters per second plus 80 meters per second will give you 15 meters per second. And that would give you the velocity. And then to figure out the displacement for the first 8 seconds, this is going to be your initial velocity plus your final velocity divided by 2 times 8 seconds, or 40 times 80 is going to be 320 meters. And there you have it. This is really number 3, not number 1, and those 3 parts.